Hi, welcome. Steef Jan Wiggers at the Scottish Summit. I'm going to talk a little bit about Azure integration. So first I'd like to thank the sponsors for this great conference. This is a virtual conference. So you see the sponsors listed here, and without these sponsors, this couldn't happen, in combination with the organizing people behind the scenes as well. So thank you sponsors, thank you organizers for having me for this virtual conference. So I'm Steef Jan Wiggers. I live and reside in the Netherlands. I work for HSO, which is a system integrator, Dynamics 365 partner. I work with ERP systems and such. I'm a technical architect or integration specialist, whatever you want to look at it. So, and you can follow me on Twitter with the Twitter handle @SteefJan. Okay, so let's get things starting. So I'm going to talk about integration. So I'm going to do a little metaphor with regards to communication. So in this case, the Tower of Babel. So you see a picture of Peter Bruegel in this picture. Basically, this is a painter from Flemish, and this kind of depicts the story of the Tower of Babel. Basically, people came together. It was one people, and they were building a tower. Eventually, that's what's described in the Bible, and they want to reach the heaven, and God kind of, disrupted the work and said, "Nah, I don't think it's a good idea." So he basically disrupted it by letting people communicate differently, by giving them, everyone spoke their own language, basically, and that led to the fact that they couldn't complete the tower. And with that regards, if we look at, the same kind of metaphor with the rise of cloud computing and SaaS providers and such, communication became apparent as well, and out of the box, these systems don't really communicate that well because each kind of have their own entity, a model, and different kind of where they're targeted for. So some are finance systems, some are logistics systems, some are HR, etc. And all these systems together, most of them predominantly are SaaS systems or reside in the cloud, kind of need to communicate with each other as well, kind of to support all these business processes for these companies that work kind of all these SaaS solutions. So for that, they kind of need to communicate as well. And in some way, they also don't speak the same language. You kind of, wished for that there was this kind of lingua franca for these systems, and then, the communication would be easier, and then, we as integration people wouldn't have a job at all. But that's not the case. So all these systems still need to communicate with each other, and kind of you need to integrate these. So if you look at the application landscape, so I'm presiding in the IT industry for quite a while. So I've seen this, like systems on-prem going forward to systems being in the cloud, which I just said. The rise of cloud computing. Data centers everywhere, AWS, Google, Microsoft Azure, kind of shape the landscape to what it is today. You still have your on-premise system, but some of these all kind of migrate or be moved into the cloud, or even natively started in the cloud. So that means, they have to communicate as well. And then presumably tomorrow, maybe everything is in the cloud, or maybe in a kind of a stack, Azure Stack type of solution appliance, which means that kind of all these systems still need to communicate with each other, then it's differently. So going from yesterday, today to tomorrow, it's kind of, you see everything kind of slowly migrating towards cloud. Predominantly now we're kind of in a situation where it is today with hybrid a lot, but also you see, or even I do some of the integration work, predominantly only in the cloud, where people or companies have moved their Dynamics or some other systems to the cloud, and then need to communicate with other systems, and they don't have no data centers or whatsoever on-prem. Looking at the journey, if you just look at what Microsoft kind of brought, with technology. So back in 2000, they had Business Server. They had this broker product which allowed systems to communicate with each other on-prem. SAP systems, Oracle, Siebel, all kind of systems need to exchange data with each other. Some was even file-based, text-based, XML-based, and that was all provisioned by the fact that you can use this product. But then Microsoft Azure came in 2008. It became GA in 2010, and that also meant that Microsoft already started thinking about, okay, but now I need to have some kind of technology similar to to this broker product I have on-prem to allow systems to communicate again, or at least, or maybe support hybrid scenarios. So then they kind of brought out Service Bus AIE and EDI Labs, which was kind of a CDP. It never came really to fruition or general available. But then they had the successor with BizTalk Services, which became GA, but again, wasn't quite the technology good enough to support that, system communication on-prem or even on-prem to cloud or even cloud as well. So then kind of you could say the third iteration of this technology came apparent, which was Logic Apps. And this was in preview 2.15 and it became GA in 2.16. So now there was this technology combined with some of the other Azure services I will talk about in a minute, enabling again systems and system integrators to allow these systems to communicate. So looking at the same kind of picture I'd drawn. So yesterday you had this product like BizTalk Server, right? And then today, you have more this hybrid type of integration, supported again by the same BizTalk Server product, enabling you to, through an on-premise data gateway, communicate with Logic Apps, API management. So there's lots of technology that, and even BizTalk Server kind of evolved, allowing this hybrid type of system integration and communication and communication and such. And tomorrow, or even today, I could say as well, you can natively integrate systems with each other, leveraging the technology like Logic Apps, but also Service Bus, Event Grid, and API management. That said, so let's look at the integration tech or the integration stack that Microsoft provides in Azure, which is labeled as Azure Integration Services, which is a combination of 4 services available in Azure. So you got the Logic Apps enabling you to create workflows and connecting systems. You got your API management allowing you to basically have a gateway towards your APIs and secure them, and kind of the quality of services basically are leveraged or managed inside this API management product. You have a Service Bus allowing you to do queuing, reliable messaging between systems or support that. And you even got Event Grid as well, allowing you to do eventing and supporting an event-driven type of architecture or integration solution, if you like. So let's look at, Logic Apps. So Logic Apps kind of, allows you to connect on-prem systems with systems in the cloud. So if you see this as the center of the world, let's say, Logic Apps, then you can see, you can connect to Salesforce, you can connect to some of the Azure services through an on-premise data gateway, which is kind of a service which leverage the Azure Relay, allows you to connect to systems on-prem. And even with API management, it allows you to connect systems on-prem, or at least you can expose some of your APIs for API management and then have them connect to other systems as well. So this allows you to allow systems to communicate, but also support your business processes, well, regardless of where they reside, whether it's on-prem or in the cloud. Now, if you look at Logic Apps, what's important to notice that it really basically revolves around connectors. So you have cloud API platform functionality offered through those hundreds out-of-the-box connectors. So the connectors for software as service systems, which I depicted or showed earlier on. This could be Salesforce, for instance. You can have this hybrid connectivity, that kind of stuff. It's all possible. You have some common custom connectors, so it's possible to create your own connector kind of wrapper around an API and expose this as a connector within Logic Apps. Although I don't see this much. I would say if there's not a connector, usually it will be done through the HTTP connector, which is a very versatile connector, very performant connector. So if the connector isn't there, then usually the HTTP connector can really do the trick for you. But in case you want to create your own type of connector and reuse over multiple Logic Apps, then you can create your own custom connector, which is available in the Azure portal. You can find that it's a simple a wizard guiding you through the fact that you create this wrapper, this connector that you can use. And then through API connections, which basically means there is a connector that kind of sits on, or is kind of an encapsulation on the API management, allowing you to choose some of the APIs, those reside in API management, and then connect through that. So basically, you have all that capability of connectivity, security, but you delegate this to API management, and then through the connector, you basically connect to the outside world. Okay, let's look at the component architecture of Logic App as it is today. There's also a preview, which I'll mention a little bit later on, but this is how the Logic App service is as today. So it consists of a couple of components. So there's a resource provider, there's a connection manager, connector runtime, and a Logic App runtime. Just important to know that this is in the background. And let's just look at this workflow that you can create. So you provision a Logic App. You subsequently create a workflow definition, which is drag and drop of shapes, a trigger followed by multiple actions. So similar to maybe workflow foundation, if you notice from the past, that workflows always start with a trigger followed by multiple actions or one action. But that kind of creates your workflow. And that's being depicted here. So once you save this, you have your workflow definition, which is a trigger task. Once a message, for instance, lands on the service bus, which triggers this workflow definition, which means that there's a workflow orchestrator behind it. That's another task, because what you create with the workflow definition is a series of steps. So there's a trigger followed by a workflow, which in this case has a for each, results in multiple tasks, all being executed and then completed, and then your workflow is completed. So it's completely task-based. This means there's no active threat management tasks. They can run in parallel, they can run in massive scale, because this resides inside the data center. It's pay-as-you-go, and this is what happens in the background. And there's at least once guaranteed execution, based on the fact that these tasks are distributed, or at least orchestrated, calls these tasks on different parts of the data center hardware, and if one of the machines says, hey, I can't do it, then the orchestrator will distribute that task to some other piece of hardware, so at least it gets executed once. And by default, there are also some retry policies for, when a system is not available for a certain period of time, so you can retry it, or maybe there's some throttle issues or 500 responses. There are some retries you can, by default, have out of the box, but you can also configure this. So one way you can host Logic Apps as is within the data center, that's the pay-as-you-go method. You can also reserve, similar to some of the other Azure services like an Azure application plan. You can also reserve this as in, this is my own set of hardware or own set of runtime, and I'm not going to share it with anyone else. So usually pay-as-you-go means there's a lot of customers on that region all using the same services, and then it's it's kind of shared compute, I would say. And with an integration service environment, you have your own compute, which has predictive costs. I think it's a couple of $100,000 depending on what you choose. It also has this VNet support through ExpressRoute. You can even go to on-premise system, gives you a lot more bandwidth compared to the on-premise data gateway. And then there is a third option. So I just beside you a URL of Tom Kirkhope, who wrote an interesting blog post about running Logic App basically everywhere. What it kind of means is that now also Logic App can be run inside an app service runtime, similar to functions. So they kind of now have the same underpinning runtime. And these Logic Apps are in preview. So you have the shared runtime, which means it's the pay-as-you-go Logic App, which you just explain what happens under the hood, similar to what you can have with a dedicated runtime. And then you can have this self-hosting option, for instance, on AKS, because those Logic Apps running on the app service runtime, you can also containerize those. Similar to what you can do with Azure Functions, you can also do a Logic App, which means that there's more possibilities because you can containerize those Logic Apps. You can also have them reside inside a Kubernetes cluster in any of the other cloud providers. You can even run it on the edge. And the new runtime for Logic Apps will be available, I think, in a couple of months. It's preview now. It will become a GA. And then it means that you can also have that option. You can already have the option. It's in preview. Once it's out of preview, I think it's a very interesting option as well. because you can containerize those logic apps in a new runtime. They can run either stateless, which means that there no state is being preserved and so they have more performance, but you can also have it stateful because you want to have some more transactional support. So this is about logic apps. So just a reminder, this is this workflow engine kind of type with all these connectors, and those pretty suitable for system communication. But there's another part that's very interesting too, and also part of the Azure Integration Service, that's queuing, because of loose coupling, having interchange messages maybe asynchronously, and so forth. So that's the managed offering in Azure for messaging. So it has this, entities like relays, queues, topic, subscriptions. Very, it's kind of platform agnostic because you can do this hybrid type of communication as well, because there could be just a company using a different type of protocol like AMQP, or it has a Java library which is supported by the service bus and then also sending messages out to the queue, and then another system can pick them up. It also supports this first in, first out, deduplication, transaction behavior. It's all there. So it's kind of pretty sophisticated service, and it was available, I think, almost at the beginning of the availability of Azure itself. So out of the box, it has this relay capability, allowing you to do this two-way communication. And the relay capability is also under the hood of the on-premise data gateway. So you install the on-premise data gateway, kind of a service, and then it enables you to leverage under the hood this relay. So if you look at the logs, you can see that there is a relay being created. So it's basically on outbound connection, going out and from the outside in, creating some kind of rendezvous. So if you want to call out, then it kind of looks it up and it's like, okay, you have to go down there. And it's kind of what a relay does. And then you have this direct communication. Another one is the service bus. So you can have one or multiple systems even send messages to a queue, but there can only be one one subscriber basically. It goes to one system. One system can look at it. So otherwise you get this competing thing. You don't want this. So it decouples basically senders from receivers. So you can get this decoupling. And then you have the service bus topics, which is one or multiple systems that can send messages to what's called a topic, but under the hood there are one or multiple subscriptions based on filtering. So you can have many to many or one to many. So this is about the service bus offering. Then there's another service which is Event Grid. So with service bus you have either queues and topics, and you publish messages, but then someone has to pull off the message. So it's push-pull, but it's a pops-up type of mechanism. The same mechanism is available, but then it's called Azure Event Grid, which also has this concept of topics. So you send an event to this topic, or it's being sent to the topic, and then you have one or multiple subscribers to it. And this can be interesting for consuming events from the Azure platform. Some of the services within Azure support Event Grid, not all of them, or even non-Azure resources. So you can have this .NET application or any type of application that can send out events to an event topic. So it also allows you to do, with this push-push reactive programming, but also more near real-time concepts and even architecture type of solutions. So a system can send out an event saying, hey, something happened, and then subsequently a handler can respond to it. So I'll explain that in a minute. That said, Azure Event Grid is just, you have your event sources on one end, which can be multiple Azure services supporting Event Grid. And it could even be applications sending out custom events based on an Event Grid schema, which I'll talk about in a second, or it could be a cloud event, and I'll talk about that as well. Sending message to Event Grid, and they can have multiple handlers, which could be a function based on a webhook mechanism. It could be a logic app, similarly with an implicit webhook. You could push those events further on for buffering type of concepts, so storage queues or event hubs, or you can offer other services, again through webhook type of mechanism. Concept's pretty simple. Publishing, and you have subscribing. So what you see depicted in the middle is kind of the subscribing type. Okay, what kind of topic or event type is it? What kind of subscriber type? You can do some filtering and stuff. So efficiently you can pull those events off depending on how you want to. So it could be multiple event handlers, could be one, or you can send multiple type of events, and then you can have one event handler based on a filter pick up the message or event. So the concept basically is an event happens within those sources. So, and those sources kind of publish those events, or those are being considered as event publishers because that's where the event took place, and it will push those events to a topic. So that's where the publish sent the events to, and basically subscribers subscribe to the events that end on those topics. So those are the event subscribers, and then you have event handlers reacting to those events. And those events, and this is important, could be either from the proprietary event grid schema, which you see on the left-hand side, and subsequently you can have events on the right-hand side, which are cloud events. And on the right-hand side is on the cloud native initiative, while the proprietary schema is on the fact that this is what Microsoft implemented. So you have two type of event type schemas. Both could be sent to event grid, but one is more cloud native from an industry perspective, while the other is more proprietary. So this is all about event grid. This is something you need to know as well. Then finally you have, besides eventing, a service bus, and a logic app, you also have API management. So what does API management bring to the table? The fact that you can have a fully managed service to manage APIs, secure them, publish them. You can have, through policies, and I'll talk about that as well. Have this quality of service type thing, some capabilities inside, kind of a facade, front door for your services. It can also be an API gateway for resources like logic apps, APIs, and functions if they expose HTTP type of endpoints and you want to secure those. The concept is pretty simple. So it sits between one end, we could say the API publishers, which publish APIs to be exposed to consumers on the other end. But it sits in the middle as an intermediate, as you can see in this picture. So you have one end, you have your API managers / developers, which could, abstract some of the APIs and kind of define those API as a proxy inside that gateway. You can do some monetization analysis because of product keys, etc. And on the other end, you have your developers that can try to learn what your API does, onboard them, discoverment. So there's many possibilities. So as an animation, you have, for instance, a API on the right-hand side, which is Contoso API through AzureWebsite.com. Then you expose this through the API management. So you define kind of an API, a proxy inside it. You define this, and then it has even a different type of endpoint with regards to DNS. So Contoso, Azure. This is what you can do to expose your APIs to the front. So they can have all kinds of different kind of endpoints on the back end, but you can expose them pretty consistently to the outside world. So you can call this, if you rename it, and then subsequently it gets to the endpoint. So it routes it back to the end. And this could be one API or multiple APIs. So you define your API, multiple operations, while these operations could be different type of functions, logic app, and so forth. So that's one end, basically what this service does for you from a gateway perspective. And then inside the definition, you have inbound, outbound, backhand. So you can place some of the policies. So you can enforce authentication towards the service that sits in the backend. So in the front end, you can define all off, and then your client needs to authenticate by going to an OAuth service first, get a token, and the token gets to the API, and then the API through a policy validates that token. So that's one of the policy you can place. You can also place restrict IP addresses, rate limiting, but also going back, you can, if there's a response of 5 fields, you can only return 2 fields, etc. So there's multiple ways you can influence in and outbound traffic and do that stuff without really doing hardly any type of coding. So from a API management perspective, this is kind of what you see. So you have your inbound backend, you have your outbound, and you can even have on error. Those are kind of the sections where you can place your policies. So this looks from a UI perspective. And this is kind of how the complete policies look like. It's XML based, so you can see inbound, backend, outbound, and on error. Those kind of is where you can place your policies. And with regards to policy, what's important to know that there's like different type of scopes. So you have the global scope, which is completely on your API management for all the APIs and products and the APIs and operations. So this could be logging, course, then you have on product, and products basically a boundary or logical grouping of APIs. So all the policy you place on that particular scope counts for all the APIs and operations. So this could be rate limiting quotas. So you can have, let's say, a certain set of APIs which you expose to a certain customer or to another department, saying, hey, these are some of the APIs that you can use. When you enforce some of the policies on the product towards all the APIs available. And then you can do this Java token validation on the API level. You can have on the operation, so there's more granular caching, URL, bodies, those type of policy you can apply. So let's say you do this get foo bar. You provide a key. So the key is enforced by the fact that you have on product, you have this subscription. It means that every time you call the API, you have to provide this API key. So that can be enforced there. The foo is the API itself, and then the bar is the operations. So in total, this is kind of, what you have out of the box with all these Azure Integration Services. API management, eventing or event grid, I would say service bus, and your logic apps. Those are kind of your tech. So I've given you some details, some of the aspects of those services you need to know. Now going forward, let's say with those tooling, you want to create, solutions to allow the system communication, exchange of data, and supporting processes. So you have some architecture building blocks. So you have monitoring and operations, you have security, ALM, you have infrastructure. Then you're talking about APIs, your integration, and messaging. So if you look at, from a bigger picture, those are your your building blocks from more abstract perspective. And then, what kind of the responsibility. So you can see this depicted in all kinds of words, placed anywhere like transformations and integration, rotating keys in ALM and source control. You have networking, high availability, disaster growth, so that aspects around infrastructure. You have security, access key, access control, monitoring is about tracing. You can read what you can see here. There's those all of the aspects within those, building blocks or areas with regards to creating an integration solution. And if I plot, for instance, then technologies available for those building blocks, then you can see, hey, API management for APIs, for where you can be a gateway for functions and API apps. So you have logic apps, you have your service event grid for your messaging. So you see some of the products in Azure plotted on site, these building blocks. You see networking, which could be subnets, network security groups, your ARM templating for your infrastructure, but also for your solutions, your key vault, for instance, to hide secrets, and so forth. Okay, so technology, solution architecture, building blocks. What about real world cases? So how does this look in the real world when you take that technology, but also with the mindset of those building blocks, how are you going to set it up? So let's look at a hybrid type of scenario. So there's still a broker product in place here, which connects to some of the on-prem systems like a warehouse management system. So these are all like more legacy type of or custom-based solutions, which aren't yet modernized and containerized maybe even and put in the cloud. So they still reside on-prem. BizTalk kind of does the transformation, sends the transformed payload through to a logic app, which is secured by API management, which then pushes that workload towards Dynamics 365 Finance and Operations. That was the name last year, I believe, or even earlier. Now it's called Finance and Supply Chain Management. So it's a name, but it's still the same app under the hood, which receives that payload and processes it. And you can, for instance, when you push out that payload towards Dynamics, you can even do some maybe transformation with a policy. So this is on-prem towards Dynamics, which resides in the cloud. So this is like a hybrid type scenario. You see API management for security reasons and the communication toward Dynamics, but also securing the logic app endpoint and does some processing, presumably with that payload. Then you can have a complete cloud native type solution. So this means that one system in the cloud, like Salesforce, needs to push some information towards ServiceNow, which is another SaaS system. So what happens in this solution, particularly, is Salesforce. Something happens in Salesforce, like an entity changes, a prospect becomes a customer. So that event's being pushed towards a logic app, which does some transformation to get it in the correct proprietary schema. You could maybe do this in the Salesforce side, but there you can also choose, okay, I'm going to send some details out, and then you take the responsibility of creating an event grid schema and so forth. So Salesforce just could push out, okay, something happened in this entity. So this is the ID, this is the identity. It could be customer or some other type of entity. So that's like pushed to Logic App. Logic App makes it kind of a proprietary type of schema, which I showed you earlier on, pushes that on top of the topic. And then you get this handler sitting in behind it, gets it, and that's like, oh, okay, something changed in Salesforce. Oh, I'm going to get the details. So that we see here, there's a policy being applied to the fact that Salesforce enforces OAuth. So I first have to get that token before I can call out, okay, give me the details of this entity. And then subsequently, the response is being transformed, as you can see, to another type of object, which subsequently comes a response back into the Logic App, which then sends that payload basically to ServiceNow, and maybe even map it to the, kind of what it needs to receive it. So in a request, enabling them to push, or enabling the Logic App to push it via an API management towards ServiceNow in the correct format. So with, transformation, translation, communication, it's not all the same. Because the magic basically resides in that transformation. No one has the same type of object structure. It always needs some type of transformation, or maybe even translation. So you need some tech too, and that's kind of where the magic resides too when it comes to system communication. Even, I talk in English, but I'm a native Dutch. But if I talk Dutch to someone who doesn't understand it, you need some type of translation as well. Or at least in my mind, the translation is being done, and then I can talk in the same language that someone receives. But it's all about transformation between one format to the other. And supporting tech could be an integration account, which is kind of placeholder for your schemas and maps doing the transformation. You can also do transformation by yourself, encoding using a function or an API. Or you can, even within API management, you can do that transformation. And you can either do XSLT for XML transformation. You can do JSON transformation to JSON text and forth. That's what Liquid comes in. So that's a open source. It stems from Shopify. Or you can even do then, the custom type of mapping, and then you leverage .NET language. So transformation is one. And the other thing that you need to, and this one I want to stress out, is when you're creating those integrations, to whether it's hybrid or it's completely native cloud, you have to think about loosely coupling. You don't want to have tight system or spaghetti with point-to-point coupling. And you want to monitor, not just technically, but also functionally. Hey, message goes from A all the way to B. I want to, follow its journey, or maybe it's got stuck somewhere. Maybe you have to think about event-driven when it comes to more real-time interchange of data and keeping systems always consistent with data. The other factor is that because you're building solutions in the cloud, another aspect comes to mind as well, because it's more operational costs. Cost management is important as well. Together with the fact that you need versioning with regards to your data, governance, but also DevOps and automation. So if I come back to that cloud native solution, for instance, right? I've explained this, but let's look at the fact that you have a Salesforce admin, you have a ServiceNow administrator. There might be some, customization necessary or some tweaking in those systems as well. So you need people on that side. And then in the middle, you have your Azure admin that can use stuff like the Azure Portal, OMS, Operation Management Suite, which allows you to do some monitoring or log analytics workspace, those kind of services you need. You need to look at Azure monitoring, alerts, budgets, etc., cost and monitoring itself. If you look at integration, API management, you have to think about security, maybe Azure Active Directory integration, or maybe you think about OAuth, RBAC, Key Vault for managing secrets, support dead lettering with the event grid. So on the subscription, you kind of have to explicitly say, okay, hey, if the message doesn't get delivered, and usually it has to be delivered in 24 hours within event grid, otherwise it's gone. But if you enable that lettering, then you can subsequently keep those messages as well, or events, I would say. And with API management, you also think about subscription key, basically our API keys, policies, etc. So there's kind of a lot of things to think about. It's not just simply, okay, system A communicates with system B, you just send a message and you do some transformation, done. No, there's more to it, also with regards to the best practices. And when it comes to building your logic app, or having this API definition, or you have some ARM plans of infrastructure, you need to think about Azure DevOps as well, and setting up Azure pipelines, presumably YAML, the more modern one, to do the deployment of your infra, so your basic setup for your integrations, but also the deployment of artifacts, APIs, logic apps, and such. Hybrid is kind of similar, but then there's a BizTalk admin you need, and maybe some transformation there. You got your Dynamics admin that needs to set up stuff too, or set this trust between Azure and Dynamics itself, and app registration. There's some logging involved. This is kind of a setup, if you see on the bottom, where all the logging is centrally being pushed to a Cosmos DB instance, which is indexed by search, which exposes a kind of API endpoints, enabling to kind of follow through what happens from, the warehouse system, all the way up, pushing data towards Dynamics 365. Also here, again, you have to think about, because partially your solution resides in Azure, so you have some Azure Monitor alerts metrics for technical monitoring, you have budgets and alerts, subscriptions, keys, APIs, protection, RBAC, those kind of, stuff you have to consider as well. Again, as a developer, some of the things you build, the logic app, the API definitions, such, again, you have to automate those using Azure DevOps. And even when it comes to BizTalk, there's something like a packaging model as well, calling the BizTalk deployment framework. So automation is in place there as well. So you have to think about that too. So in generally, those are kind of cases I've built together with others. Hybrid solution, a more cloud-native solution. I've done several others, but kind of the same paradigm with, those are the best practices, etc. And there's another thing. There's another way of doing system integration with systems that don't have an API exposed, or a little bit harder to extract data from. And this is where automated fits in. So that's the question mark. Where does automate fit in? You might even think, hey, why is he talking about, Power Automate, which resides in the Power Platform, Microsoft Cloud? What's that got to do with integration system communication? Well, the fact is that there's one capability I want to point out with Power Automate, which is called robotic process automation, allowing you to record tasks, because there's kind of Selenium type of technology involved as well, and automate a task and then play it back. And what it means is kind of when there's a system that doesn't have really APIs, it's not hard to expose or get data out. You can also, by clicking, and basically get the data out of that type of system. So you can use the UI flow connector for RPA, and then it's kind of, you launch a recorder, you record your clicks, and then you build your flow. And to visualize this, I have an animation from Kentware, which shows you a kind of a system that's not open, where there's going to be kind of a recording of some of the data inside within the application itself, and then it's being ported towards an Excel. And then you have that data, so you extracted the data and pushed it into another system. In this case, it's Excel. And there's a YouTube episode, or on YouTube, there's an episode where Ken goes more in depth into what happens with this type of technology. But just to have to think about, hey, there's another way of doing extracting data and getting into another system. So system communication from that perspective. Combine these technologies, you get Power Automate, logic apps, and functions. Those are kind of tech you could use, and they also have this kind of let's say dependency, or let's say ways you can leverage those technologies together. So you can create functions which you can consume in a logic app. So the functions can help you with some of the customizations, and then you leverage those in a logic app. You can also have those functions inside Power Automate and leverage it, but you can also push a Power Automate flow towards a logic app if you want to have more control, etc. So that's kind of how it really kind of fits together, I would say. Okay, The last part is, okay, I've talked about tech, some real types, I talked about real world use cases. Okay, how does this fit in the market? Because looking at this tech, there are other cloud providers as well, or SaaS providers have kind of also bring to the table solutions that allow you to do system communication. So one is the Gartner Quadrant for Enterprise Integration Platform as a Service. So Logic App, for instance, or at least the Azure Integration Service, you could see as a package or a kind of a solution which it sits on the Azure platform, allowing integration with other systems. But there's also MuleSoft, Jitterbit. There's other companies out there that have similar type of software, allowing you to, which have connectors and which allows you to do transformation and enabling you that system communication as well. But what's important to note here that Microsoft is also here in the leader quadrant. So, those services, Logic App and Service Bus and Event Grid and API management all have evolved as capabilities that, stand their ground with other competitors, but also they're all in the leader quadrant. So this also is the fact for API management, which last year also entered the leader quadrant. So this is also a very mature product, resides within the Azure Integration Services kind of suite, as you say, but it also can compete with X-Wave, with Kong, which is an open source API management, MuleSoft, or the Apigee, which is being bought by Google in 2016, I believe. So also here it's serious tech. And when looking at the Power Platform, again, also from last year, it also shows that there are, a leader in the quadrant. That's also serious tech in this compared to OutSystems and Mendix and such. So all in all the technology enabling you to do system communication on the Azure platform / Microsoft Cloud is serious tech you can use. It's proven. I've showed you with some cases where, these kind of solutions all reside in production as of today or since a couple of months or years. So the key takeaways is basically you choose the tech or some of the tech based on your requirements to build up these solutions for your system integration for your customers. There's like Power Automate, Logic App, Azure, even Durable Function you can use to support workflow, but they're not competing technologies. Same applies for Event Grid and Service Bus. It just depends on your requirements. If you need real-time processing or consistency between systems, then maybe event-driven architecture using Event Grid could be a good solution. When it comes to decoupling of systems, Service Bus, or even in hybrid scenarios is a good choice as well. And the other thing is just apply your best practices. And I want to point out that some of the things I said, are applicable, but you can also really look at the Azure Well Architect framework, which can help you as well with regards to security, availability, reliability, and such. Okay, there are some resources to explore. So I think the slide decks, even my slide deck, will be pushed out to you as well. So there's integration service, you can find stuff. Coded blog, for instance, is a good one. I used to work for Coded. I moved on to another company, but they've got really some good resources. Integration patterns, user group, Microsoft Learn. There's tons of stuff that you can find with regards to integration. So finally, I would like to thank you for attending it. It's virtually, so it's not in person, unfortunately. I like Scotland, for instance. I've been there many times. Drinking a beer, exploring is a great landscape and stuff. It's great. It's got some good whiskies and such. But yeah, not this time. But anyways, thanks for attending it. You can find my LinkedIn profile, Twitter handler, email. So yeah, if you got any questions with regards to integration service and such, and how this works, or you need to do some soundboarding or maybe exchange ideas, you know where you can find me. Okay, so again, thank you. Enjoy this conference, other sessions you will go to. Have a great day, and who knows, maybe we'll, when COVID goes away a little bit, we can meet in person again. But anyways, thank you and goodbye.